When printing doesn't go well, what is the first, almost by default, prime suspect? The possibility to consider seemingly before all others. The issue always mentioned in manufacturers' FAQs and just about everyone's forum responses. Wet filament. And often it's the right suspect. So here's what I do to take this off the table. Welcome to Barrett Works. So just to review, FDM filament tends to be hygroscopic, meaning it takes up water from the air. Some filaments, like nylon, are tremendously so, others to varying degrees. When you send wet filament through the melt zone in your hot end, the water it contains rapidly vaporizes, increases in volume and pressure, creating bubbles, messing with flow. The possible result is sputtering and popping at the nozzle, poor layer adhesion, pitting and cratering, inconsistent extrusion, rate and width, and sometimes even changes to the structure of the polymers that make up the filament. So bad. I don't want anything to do with any of that. So I do two things to remove this variable almost entirely from all my printing. First, I dry all new filament. I do this without exception by cycling spools through an EDry cabinet when they first arrive. This, of course, requires a bit of planning and forethought. I can't order a roll and print the moment it comes, for example. My EDry cabinet is set to maintain a relative humidity of 3%. It fluctuates a bit during its cycle or as I move wet filament and desiccant into it. And it dehumidifies the cabinet without heating the air. It uses a circulating fan and a permanent desiccant pack mounted at the back to absorb moisture. And then, periodically, automatically, it isolates the pack from the cabinet with flaps and heats it to dry it, expelling the moisture outside before re-exposing the now dry desiccant to the interior of the cabinet. Everything inside the cabinet remains at room temperature, so there's no torturing of filament or spools by baking them. It's quiet, it uses little power, 0.1 watts when it's periodically running its circulation fan, 60 watts when it's periodically and much less frequently baking the desiccant with the flaps open. The overall total, I hooked it up to my kilowatt meter to get these figures, was that it was using power at the rate of 2.5 kilowatt hours per month. At my local rates, that works out to 50 cents for the month. I'm cutting in from the future to say that I haven't entirely abandoned old style filament drying. So I have my old dehumidifier dryer, which I made a tall ring for so that I could put 2 spools of 1 kilogram filament in it, plug it in. It's got a timer. I set it for 4 hours or 6 hours and put the top on it and away I go. And I still have the shelves that came with it originally, so if I want to dry some of the desiccant containers at the same time, I can put them on the top. This is obviously quicker, but as you can see from these tables, it uses a great deal more power. So I only use it when for some reason I need to dry some filament right now, and in 4 or 6 hours it's ready to use. Otherwise, I stick with the EDry cabinet. Second, dried spools go into and are printed directly from single spool passive dry boxes that I make from 21 cup Rubbermaid cereal containers. These have easily swappable desiccant holders, which are stored in the EDry cabinet to re-dry for subsequent reuse, and have proved to maintain my filament's low humidity despite any possible leakage or the consequence of briefly opening the boxes when loading and unloading. If no dry boxes are available when a spool comes out of the cabinet, or if the spool is the on-deck filament for one of my regularly used materials, then it goes into an Eobos filament vacuum bag, which I found to be reliable and durable. If you found others that have worked well for you, let me know in the comments, but these have been good. I'd recommend them. For each filament I commonly use, my storage shelf then has one dry box, and next to it the on-deck spool of the same filament dried and waiting in a vacuum bag, and also one of my desiccant containers inside the bag. When the dry box spool runs out, I move the on-deck spool from the bag into the box and order its replacement. When it arrives, it goes into the cabinet first and the process repeats. So for filaments I use at higher rates, I keep more than one spool on deck, and I also periodically move some of the more hygroscopic filaments from the dry box library back into the EDry when there's an open space, just to be thorough. I designed and printed a shelf for the cabinet which allows me to store 8 1 kilogram spools plus dozens of desiccant containers in 2 custom first-in, first-out dispensers. Desiccant containers I pull from the dry boxes go into the top slot of these dispensers, and sometime later, usually weeks, they eventually reach the bottom, as those before it are withdrawn and the collection rolls down each time, drying all the way. So obviously this system, as I've set it up, is tuned for the rate of filament use of a personal makerspace, not for a print farm. Now I know the EDry cabinet sounds too good to be true, but it isn't, except that it's expensive. It's one of those pay once painfully, then benefit for a long time kind of things. It was just under $600, including shipping, some years ago via a kb3d.com group buy. And I see that kb3d.com now lists them as a regular sale item for just a bit more money. I've also heard that they will have some of the larger models available soon. So check that out. Okay, the dry boxes. So all total, I spend just less than $14 per assembled box, buying the Rubbermaid container and then adding some mostly printed parts. I make 4 or 5 of these at a time as I need them, buying the bare containers from my local hardware store or from Amazon if I have to. I put them together assembly line style, so I'm not sure exactly how long it would take to make just one, but I can assemble 4 or 5 of them in a half hour. After all the parts needed are printed, of course. I'll put the parts I use in the description along with costs and links. This is a long-established dry box approach that was already in Thingiverse and then on printables even as I began my first involvement with 3D printing. There are quite a few variations for setting them up. Some support filament spools on rollers that nest into the bottom of the container. One at least mounts rollers on the lid and uses the containers upside down. Some mount brackets for an axle by screwing through the sides of the container. Some suspend brackets on a frame that nests in the bottom of the container. Many have somewhat complicated, and I think hard to get to, desiccant holders built into the roller or frame design. And most use 608 skateboard bearings. So my version is guided by a few core goals. Puncturing the container as few times as possible for obvious reasons. Actually, exactly 1 time for the filament port, in fact. Making it instantly simple to swap a wet desiccant container for a fresh, dry one without removing the spool. Dependable spool turning, not too hard, not too easy. And the ability to monitor humidity in the box dependably over time without maintenance. So, to meet the desiccant swapping goal, I use a shortened 34mm version of G-Drag's silica gel spool container from printables.com. I've created a mount for it that I print out of flexible filament and that grips the knurled top of these containers just enough so that they hang in place but can still be pulled free with one hand when swapping. I hot glue these mounts to the underside of the lid, which is the element of my boxes that most frequently needs re-gluing. With the desiccant mounted under the lid, it is quick and simple to remove the lid, pull the desiccant free, press in a replacement in its place. I change desiccant literally in 6 seconds. I use a central axle to mount the spools, not a skate or other spool edge roller design. The axle I use is a somewhat modified version of Brad M10000's dry box spool holder, again on printables.com. I hot glue the axle, or what he calls a screw, mounts to the side of the container, just as he does. But I position the mounts with a custom jig, so I don't have to measure and mark their location beforehand. I put the jig into the container and I can immediately apply glue and attach the mounts, no messing around. Again, only seconds. I've removed the 608 bearings from the axle as I found my spools turned too easily and sometimes unspooled after just a gentle tug. In place of the bearings, I have plastic protrusions, nubs I call them, that rest in the mounts, providing a plastic-on-plastic bearing surface that moves easily enough, but has enough drag to avoid runaway spools. I use PC4 M10 PTFE tube fittings to create the filament port with an M10 nut modified and printed from a download from a CAD file from McMaster Carr to back up the fitting inside the box. I modified the nut to include a smaller internal diameter as a hard stop for the tubing as you push it in from the outside. And I flared the inner surface to make it easy to feed filament. For years, I've used standard, cheap, round hygrometers in these bags. They're the hygrometers you see all over the place in dry boxes and cabinet designs. I hot glued them facing out on the front surface of the box with 2 small drops of glue. I'm not doing that anymore. and I'm about to begin removing all of them. One, they eventually run out of power, and I have to do a fiddly button batteryectomy to make a swap, which also creates waste I'd prefer to avoid, as almost all my battery use otherwise is rechargeable. And two, I've learned they're not necessary. Between noting the color of the desiccant and swapping it immediately if it has darkened at all, and adding cheap card humidity indicators, I have no trouble confirming the ongoing implied dry state of the filament. And yes, I've done spot checks of weight for weight measurements over time to confirm the implication is correct, that spools are not taking up moisture. So, the result. One less failure point for all my printing. One less possible cause to investigate when problems do occur, and one less thing to think about case by case as I print from a wide variety of materials, many of which remain on my shelf partially used for years and yet are always ready to go. It was a lot to set up, but it's been a great system for the way I use my printers. I hope, if you've watched this far, that something like it might be of some use to you. Please reply in the comments if you set something up yourself and you'd like to share. If you haven't subscribed yet, please do. And thanks for watching. Catch you next time.